Okay, let me see if I can. Should be able. Okay, so I have audio, that's good. I have Minecraft setup, that's great. So, today, yeah, sorry for being a bit late, I was having technical difficulty with some of the LATTCG repo, but it's fixed now, so it's alright. And why there was technical difficulty? Because today's subject is Latticg. I'm seeing that there is already some people. That's nice. So I'm guessing we can start. Of course, the whole video is recorded, so you can watch it afterwards. I mean, you are not forced to watch it. It's usually between 1 hour and 1 hour and 15 minutes of well, me speaking, so you can, well, skip ahead and so. But just to, well, give you what we will do in that video, we'll explain, well, what we will do. So Latticg, as you may know, is currently the library to, well, not crack, but make using LCG way easier. Like we can reverse it way easily with Latticg. It's a play on word, of course, because it's lattice and LCG, so Latticg. If you didn't watch Matthew Bullen video, well, I highly recommend you to watch them because, of course, they are great. So let me find Matthew Bullen YouTube. And yeah, if we go on his YouTube, there is two last video, one about general introduction and one more specific about lattice. Today video is not about really the math behind, it's about how to use the tool, so it's a bit different. But still, if you haven't watched those videos, maybe, well, you might miss some stuff, so yeah, just FYI. But of course you can watch this video afterwards, so yeah, it doesn't really matter. Anyway, so today is explaining Latticg API, which was made by Earth Computer. Then we will see an example of use of Latticg. And then we will see how to use it in general case. Because actually, oh, let me cut the music, because of course I didn't cut it. Because, well, yeah, if you need to use Latticg, well, actually you want to have the general case, because, yeah, what I will present is just one example, but actually you can do a lot of stuff with it. And currently with the API it's way easier than it used to be. So, first thing you need to know is actually the repo, I guess. So the repo is on Matthew Bullen. Hi everyone, I see that there is a few people, that's nice. So it's on his repo, so yeah, it's quite hard to spell the name, but anyway, it will be in the description. Let me put it right now, so actually it can be later. Okay, now it's in the description, so no excuse. Of course, there is actually an easy way to have the documentation, which is to go to latticg.com. So if you go to latticg.com, you have the Java docs of the Latticg lattice API. And if you go to marvin.latticg.com, actually you don't need, but yeah, that's where actually the stuff are hosted. And if you browse the repository, you will see the different version of Latticg and the latest one, which is 1.03. And you have the Java doc, jar, the source jar, and the jar, which is generally what you actually need. And of course, to use them in Gradle, you just need to have that line plus another line, and we will talk about that when we explain actually how to use it. So LATTCG, let's just take a look beforehand at how it is composed. So if you clone the repo, which actually you don't need because it's a library, but just explaining some stuff. So currently there is well, 3 main directory. Math one, you don't ever need to go in there. It's actually the important stuff which are done. So you have a LU decomposition, you have a LLL here, you have a BKC, the enumeration, you have well, all the stuff which are important to make it work. So that's the backend. You have the reversal, which is the API made by Earth Computer. And yeah, that part is actually the part you will interact the most, not only the dynamic program, which is actually what will give you the, well, the seed you want, depending on the condition. And there is a utility function which has some stuff you might use. So there is a utility for the LCG, so with the multiplier, addend, and modulus. Of course, there is the same in Captain Wutax repo, so it might conflict some names, so make sure you are importing the right one, even though they are compatible at 100% because they are the same backend. There is stuff in the math, so if you need a quick GCD or some stuff and you don't want to bother, you can just import them. There is a pair because yeah, pair is always useful. There is a rand to, well, mask the random by Java util, and some, well, utilities, yeah. And there is also the random reverser, which is old API, which is not recommended to use anymore. And that's all you can actually find it on the repo. So if you go on the GitHub, you actually have all the link you want, so you can just go there. And in, well, Javadoc, you have everything you need. And the main part you want to go, it's a dynamic program, and there is everything you actually need to see. So that's what actually the repo is. Now how to import it. Actually you need to add the maven as an URL, an external URL. So that's easy, actually you just put the URL maven.latticg.com, and then for Gravy you just put that line. Of course you change the version to the latest one. I forgot to update that, but yeah. And you for Apache, so for Maven you just use that, and for Scala use that. I mean, it's all in here if you want some, so you can use them for Perl, for Builder, and so on. And basically how it is used is really simple. So if you go in test here, so in the test I just have actually, well, 2 lines. That one, the Maven I am importing, and then I have the implementation of the latest jar. And that's all you need to make it work. So that's the presentation, the quick presentation of API. So the API was made by Earth Computer. The main repo is from Captain Wutax at the beginning. And the math is from Mathubelen, of course. And I did a few, well, I corrected some of the LLL and KZ, but yeah. So yeah, mainly that's the people that contributed to the repo. So that's a lot of information. I think a lot of you are, well, bored by this, so let's go to an example, because actually that's what matters. So I tweeted something, maybe not a lot of you saw it, but basically horses have a speed, a certain speed, and if you play, well, if you play a bit of Minecraft, you know that, well, the speed differ depending of the horse you are taming, depending if the parent are speedy, and so on. So to get the fastest horse, actually it's quite tricky, because you you need to do well, a lot of taming and a lot of breeding to get them. If you look a bit in the code, you see that the random speed is actually determined with the random object which is initialized for each of the each of the entity. So there is a new random called. So if you go here there is a new random for the entity, and it's called with next double, next double, next double. And that's actually very interesting because you want to max out this equation. You know that next double is a number between 0 and 1.0. Bonjour. There's some French people, okay. Yeah, I'm speaking English today, so yeah. And exclusive 1. So you want something close to 1, but not actually 1 because it's not possible. And you want that to be the maximum, you want that to be the maximum, and that one also is maximum. So you want 3 next double in, well, right next to each other, and which are close to 1.0. And that actually can be done quite fastly. So let's, oh, it didn't finish. Yeah. Let's maybe open 1.12 because 1.12 I know is a bit faster to open. So yeah, that's 1.12, and of course, so let's create a new world. Up. Should take some second string, so of course oh, a Swiss, nice. Yeah. So yeah, of course to Minecraft, and it freezes. I don't know the guy that say that Minecraft is lightweight. It's not true anymore. Like in 1.16, it's actually not lightweight at all. But yeah. So, and of course I'm spawning in ocean. Oh, right. So let's fill some block here. Let's take 100 block and let's put some stone here. Let's take ores. Okay, and let's tame it. So I just need settle for afterwards. Okay. Yeah, taming a horse takes some time. I mean, I know that I could use some stuff, but like I want just to do it simply by reading it. Okay, can you love me, please? Yeah, okay. So now I can just saddle on it, and I can ride my horse. So, as you can see, it's already quite fast. Actually, it's the fastest horse already. But now let's see in 1.16, so because it's actually a bit easier because you actually can see the all the stuff about the horse. Yeah, but basically, yeah, I already show you that I can get the fastest horse, but I wanted to do it in the other way. I should have preloaded 1.16. Anyway, in the meantime, we can actually look at what I did in 1.12 because it's actually quite simple. So if you go at entity horse, you go at the bottom horse here. So what I set the seed because it's a new random. You can't actually well just set it because it's not set by the code, so you can't do anything about it. You can just manipulate the time or something about it, but you can't set the seed. So here I'm just setting it, so that's okay. And I'm setting to the fastest seed that actually exists. And then I compute that value. And if I go in my terminal, as you can see, I'm getting the fastest value, which is 0.3374. And as you can see, it's actually, yeah, the fastest value you can get if you go in a calculator. So let's just agree, this number is 0.45 because it's just because it's a double and that's a weird number. But so that's 1 plus 0.3 because we next double is 1. Let me get that value here. So actually I can show you what I'm doing. So first one is 0.45. Then we take the mass value of next double, so 1. 1 times 0.3, so that's 0.3. 1 times 0.3 and 1, so we add that 3 times in total. And of course we multiply that by 0.25. And we get that which is the actual maximum value for the speed of the horse. And if we look here, we are actually very close. We are like just at the 4th decimal difference. So that's actually pretty good. And just by getting this seed. And that's actually the only seed that does that. But now let's go to 1.16 so I can actually prove that what I'm saying is not some random shit. Actually, do I see my screen when I do that? Yeah, okay, so we can go full screen. Let's go game mode. Oh, forgot to open it to LAN, of course. So game mode, creative. Okay, let's just go on tops of the ocean, fill, here, 100, and 4, 6, okay, 6, stop. Yay. Okay, horse. And we'll just look at his stats. So that's data. Get. Oh, I need to. Yeah. Okay. So the speed, motion, ungroup. Oh, movement speed here. So here the movement speed is 0.9. Well, it's 0.2 approximately. Let's get it from another entity. So that will be. Let me look at it. Of course, it's not that easy. Let's get that one. And as you can see here, movement speed is 0.24. So actually we are pretty close to the max speed already, but we are not getting the max speed. So to get the max speed, we actually need that, and that to be maximum. And that's a use case of Latticg. Yeah, I think I lost everyone. That's great. Anyway, let's go back to Latticg because it's the interesting part. So if we go here, I already made it. So if we want to get the max value in Latticg, we can actually do it quite simply by, well, that's using the old API, but I will show you how to use the new API. So the first thing you do, well, you are consuming some call because there is some call for the jump or the alpha thing. So yeah, we don't care about those, we just keep them. Actually, we could start here and just go back because it's too to skip, so that's easy. But yeah. And then we add a call, which is add next double value, and we specify that we want it to be greater than that value and, well, of course, less than 1.0 because that's the maximum. Could put any value here, it doesn't really matter. And we want the min and the max to be inclusive because, yeah, that's easier. And then we get also, and if we run that, so let's just run that, we get, of course it will take some time because yeah, I'm guessing I lost everyone. I'm sorry, I mean, this stream are not meant to be like super entertaining, like they are meant to be explaining some stuff, so yeah. Anyway, we get only that value. which is the seed I use. Of course, you need to XOR it because it's not the full seed. Well, it's an internal seed, so because Java XOR at the beginning when you call a new random, you actually need to XOR it when you are setting it. But now, if I want to have seed that are, well, a bit more, well, less restrictive, we can just remove 1.9, and then we will get a lot more seed. So yeah, this time it compiled a lot faster. And as you can see, we found 2000 seed. So as you can see, well, yeah, we actually need to make the restriction a bit, well, more restrictive to get more seed, well, less seed and be, well, closer to 1. And yeah, with LATTCG it takes less than 1 second to actually get all the seed that satisfy these 3 requirements, which is well, like a fuck ton faster than anything you can imagine, because just specifying these 3 call are actually not trivial in, well, brute force pattern or something like that, and will take a lot of time. But here we can do it in, well, 1 second, and that's it. So now that we actually have seen one use case, let's see how we can do it in, well, normal repo. So I've set up test LATTCG, which I have imported the Lattice repository, and we go in the main. So that's all API, so that's using random reversal, but actually it's deprecated, so we remove it. And we introduce a new one made by Earth Computer. So of course it's all in the Javadoc, but here I'm just brushing it. So yeah, we are defining a dynamic program. So the dynamic program, as you can see, is the one which actually builds the program. The goal is to have it as just a file you give it, and you will have all the, well, the restriction you want in it, and it will do the best it can do to actually satisfy most of the restriction or all the restriction. But currently it's, well, you still need to do it in the code, but it will soon come alive. So you create it for the LCG Java, but actually you could create it for any LCG or even a different type of pseudo-random generator. It's just a matter of time till we support a lot more. Then you are adding some call, so you do Java call. If you look, well, just add some call. So Java call have, well, the different Java call possible. So next double, next long, next boolean, next float, next int, and next int with a bound. Hey, pixel 0x. And so yeah, let's, for example, well, put no next int. It was, I think, TCG, it was a next int 8. So let's put our next int 8. Then we can specify what we actually want. So for example, we can say that it's not equal to, so it will be all the value except 1, less than equal, less than, greater than, and so on. So let's just for now less than 8, which is actually all the seed space. Then we add our 9, I think it was 9, yeah. 9 and next 9. And that's it. We just call reverse. So yeah, if we don't call reverse, we don't have a stream. We have the dynamic program that we call reverse on it. And on the stream, we can just get all the value. So if we run that, we actually have the same stuff which will be printed. Of course, it's building for the first time, so it will take a bit of time because Gradle. Yeah. Okay, and it's compiling and it's running, and as you can see, we got exactly the same seed. If we go here, so it will be, yeah, here. Of course, I'm not at the right position here, and that's exactly the same value. Yeah. So that's just a new API, and it's a bit, well, it's a bit better to use because, well, you can, well, specify stuff in a nicer way. Yeah, I opened that. That's not good. Yeah, just yeah. Okay. So now that we have seen the example, we can actually see something more interesting, which is actually using Latticg in general context. And how to use Latticg? Well, it's simple, really. You go in Minecraft code. So let's take 1.12. You find something which is interesting for you to tinker. So you see a lot of code which are next to each other. So let's take, for example, one of well, it's not my favorite, but it's one of the most common nowadays because a lot of people use it. So let's go in dungeon. So WordGen dungeon. And if you look in WordGen dungeon, there is 2 burner call at the beginning. So those 2, we don't care really about them, but we can specify them if we want. Then there is actually the loop, which is for all the block of the floor. And then there is if mossy next info is different than 0, and if cobblestone, then next info was equal to 0. And that's actually very easy to specify. So we just add, for example, well, let's take, yeah, here, let's put our dynamic program. And for, well, for E, and let's go for a 99. Okay, for a 99, and let's go, yeah, just, it's in a dynamic program, yeah. So dynamic program dot add, and here we can, well, let's add, for example, Java call dot next info and not equal to 0. So if not equal to 0, we are expected to have a mossy. And so yeah, if from well, let's say that we have the sequence, so it's a string sec, and it's like 0, 0, 0, 1, 0 for mossy, and 0 for cobble and 1 for mossy, for example. And if sec and we get y I plus yeah, j, yeah, of course it's gates because yeah. Can we actually get char? Oh, right. Yeah. Let's just convert that to an array because it will be easier. So 0, 1, 0, 0, 0. Let's just call that int array is equal to, so it's a cobble, so it's equal to 1. So it's 1 here. And we do that one. And else we just do the other one, which is equal to 0, of course. And what is always false? Oh yeah, because I forgot to add a 1. Yeah, for example. And that's actually what we do in the dungeon cracker. It's just that. And afterwards, of course, we need to reverse it, and then for each we actually print it, so system.out and print it. And yeah, that's actually just it. We collect the sequence, we go through the whole stuff. If we don't know, actually, there is a third condition. So that's actually if it's 1, because if that's 1, if it's 0, you add. And if it's not, then we actually just skip. So we can just put like so, and less than, can put 4 here, and that's it. And actually, yeah, we have a full dungeon implementation here. So yeah, that's really easy to use as an API, and it can solve a lot of problems. So, for example, yeah, that was just because it was most common use today. Well, it's common usage of Latticg. But if we want, for example, to find, let's say, so yeah, what was dungeon? Just erase that. For example, all the eye, well, you know, the 12 eyes, like Matthew loves to find them. So if we go at the portal room, so portal room, and if we go in there, we can actually see that here we have the eye here. So what we need actually is random next float is greater than 0.9f. So we just add more calls, so dynamic program dot add Java call. It's a next float here, because every call is mapped. Well, not all of them are great, but like next int non-power of 2 or non-multiple of 2 is actually bad at using it, but yeah, that's just a minor detail. And it's greater than and 0.9f, and we do that for 12 times, so 12 times, and we reverse that. So if we go and we run that, no, don't want that. And here are all the 12 eyes seed, well, chunk seed. Actually, we need to reverse them, but yeah, as you get it, it's quite simple and it's run way faster than what you could do on, well, like simple GPU or so on. It's already finished and it took like 17 seconds plus building and so on. So yeah, that's actually not hard to do nowadays. Yeah, you can find any problem in the Minecraft source code, which are some calls, and you can reverse it with Latticg in no time. So you can do it for let's say yeah, no, let's not take enchantment. Let's take the end. Yeah, the end, of course. Yeah, of course. Spike. World gen spike. So spike generation. So maybe you recognize that one, which is actually to go generate the spike. So it takes a random with the word seed. Then it takes a random next long. It takes the last 16 bits, and then it gets the spike, which are actually just a shuffle over the collection with a new random using the value of before. So that's actually really easy to reverse. So again, you put your array of data, so array, and you just go through and yeah, you reverse the state. It's really easy to use, and yeah, there is not much to actually discuss about it because it's just a nice API, and like I could show you a lot of examples, but yeah, I don't see actually the point to show you the example. I think it's better to tinker with it and actually yeah, play with it. And of course you can find also documentation on latticg.com, and you can always go on, well, on Discord and just ask us a question about it. So yeah, I think I have a few more things that I want to show, which is actually so it's not really related to Latticg because the Latticg part are mostly done. It's done for something else, so let's click on my profile. Yeah, I just want to go to my profile, please. Don't want to go. Okay. Okay. So I think, yeah, I updated that part and that part. So I updated the SSG example and the SSG output. It's currently sanitized and everything is in it. So that's so as you saw, we got all the 12 eyes chunked, but actually we reversed them already. So they are all in that nice file, which is actually 400 megabytes. So yeah, it's small when it's compressed, but when it's expanded, it's a lot. And if we go in the repository, so here, Seedfinding tutorial, SSG example, So I actually made also utility unit. So in the build.gradle, it downloads the file and it extracts it here. So those two files are actually the one you need. I close Minecraft in the background because those are actually taking a lot. Yeah. Okay. Yeah, because yeah, it's huge. It's 400 megabytes. So yeah, don't open it. So you can actually, yeah, you get all the data, and right now, yeah, you have also the 12 eyes seed. So if we, for example, oh, did I close Minecraft? Of course, yeah. Of course, I needed to close Minecraft. Let's play 1.16.2. Yeah, yeah, I have a lot of Minecraft. Getting the assets, yeah. Okay. And of course, I debug that. Don't want to debug it. I just want to run it. So now what are actually needed to be done on that is actually well, finding the best route. So if you, for example, open it in admist, I don't have admist. Darn it. I don't have admist. Something. I can use mind map. So I can use mind map. Okay, let's just run it. Okay, and it's all turning. Yeah, I need to stop using that laptop. It's so bad. So yeah, using generally, well, as you can see, it's finding. Okay. So the main goal is just finding, um, well, some coal. So yeah, you find some coal that happen consecutively or not, because you can actually specify how much you want. And with those, you actually just write the code for, well, the call in dynamic program, and that's all you need to use the Latticg generally. But now let's take a seed, which is let's reduce the sound a bit. Okay, and let's go load it. So yeah, creative. Yeah. So you need to go at position, that position, and that position. Okay. Come on, let's go. I want to speedrun that seed. Yeah. A lot of the community of Seedfinder, of speedrunner want to, well, finish that project, because then they could actually beat every record with the, well, best seed. But actually we need to route it, and to route it, it's actually not easy, because you need to specify all the requirements. And the monkey MC. Where is the monkey? Yeah. And that's actually hard, and that's why Captain made all the I have the seed cracker, of course. Seed cracker off. Let's not, yeah. Let's TP to that coordinate. So 80. Oh, of course, I need to TP myself. So okay. Did I miss something? Oh, there's no comma. Okay, there should be. Yeah, there is a 12 here. So as you can see, there is a lot of 12i in that stuff. But if you load that seed in my map, you will see that actually it's not great. So let's take it back. from SSH example. So it's that one here. Okay, and so the Stronghold is close to spawn is here. So actually it's far. If I recall correctly, it's let's close. Oh, died. SH example. It's the distance is yeah, 1,100 meters away from spawn. So that's quite far. So actually the goal is to find a ruin portal, which is right next to spawn. Well, spawn. Then also village, to have the tools and everything. And also, yeah, you need obsidian to go back to the actual position. And then, yeah, you take the portal, you go in the Nether, and you just go out directly in the Stronghold, and that's it. Like, it should be like a few seconds to go there, and because you don't need actually a place powder, you don't need well, maybe you need an underbar to go in the end, but yeah, you just need some bed, and yeah, you can go in the Nether and just beat the dragon, and you can do that in yeah maybe less than 1 minute in task, or maybe yeah less than 4 minutes in normal gameplay, and yeah the goal is to route the well the route, get the best way to the guest path to go to the Stronghold the more efficiently possible. And that's possible thanks to caplib and capslibs and so on. So that's something, yeah, we will tackle in the next few, live stream. I think I showcase a lot of libraries, so if you recall a bit, we did in live stream 0 the features, structure mainly. Structure and features we did in livestream 0. In livestream 1 we did biomes, and we explain what are how are made the biome and how to use the library. In livestream 2 we saw we saw in livestream 2? I'm already lost. Can I already? Yeah, I just want to see my channel. Livestream 2, what is yeah, livestream 3, my bad, because I indexed them to 0. Oh, it was the noise generation, so that's for terrain. Actually it's not relevant to Seedfinding because you never use terrain. Livestream 3 was about mainly recursion, so it was about the mineshaft, which could be, useful, maybe, don't know. Stronghold, which we use to get all the closest stronghold with 12 eyes, so we use that part. And also the fortress, which could be useful for routing the seed because you could actually go fast. And today in livestream 4, which is actually the 5th livestream, we saw how to use Latticg, the main line, and how to use the API of Latticg. So now that we have actually all the building block, we can actually go in the next live stream and actually 5+, find the best route for for speedrunning. That's one of the goal, and another goal is actually to showcase some biome finding. So largest biome, but actually fast. So we'll implement it so it's actually fast. Largest biome, the most biome near spawn, and more of course. So that's because we saw all the building block, we can actually do all of those, and I hope we can do that in the next live stream. I have one live stream I want actually to make beforehand, so maybe that will be live stream 5, which is actually loot, because that's actually important for speedrunning. So loot generation and cracking, because you can use LATTCG for that, and it can be quite fast. So I think we should tackle first load generation in the next live stream. Then we can go to actually do the stuff about the next shoot and so on. So I hope it was clear enough. I mean, it was, yeah, mostly about LATTCG today. So of course all the links you need are, well, description, because you have the link to the main repo, so you actually have the link for the Java doc and the Maven and how to put it in your project. Yeah, of course, if you have questions, just ask them because I can answer them easily. And Cap and Matthew and everyone in Monkeys can mostly answer the question. And yeah, the next live stream will be about actually routing this seed, because that was found like so let me find actually the time where it was found. It was found on August 5, and since August 5 we didn't do anything. Well, we did improve a lot of things, but we didn't do anything on both seed. So yeah, it's time to do some stuff. So that will be about yeah, this week, I think. So tomorrow, yeah, tomorrow there is no live stream, but Wednesday we will start about yeah, I think loot, and then yeah, Thursday, Friday will be about routing for speedrunning. So that will be some live coding. Of course, it will be not very interesting, but if you have a question, yeah, just ask them, because I can answer them and show some example, and maybe it will be clear if you are missing some stuff. So yeah, thanks for, well, being there. I guess we will see you Wednesday, same hour. Thanks. See ya.